For better or worse, the crown has landed on my head.
She rules an empire at 25, under a crown fit for a king. She rules from the inside.
See, that's funny.
She rules with her mind. And she rules like this.
Oh, hello.
I will not be bullied into submission.
With superpowers.
Respect. Get some.
With a sharp knife and Michelin stars.
We're the strong ones, and you can't break us.
We are the optimistic, the fearless.
Mic drop. Man, where my girls at?
Brave, strong, and relentless. Long may we reign.
I want a woman in the White House.
I, Claire Hale Underwood,
All right, am I on? Okay. Hi, everyone. It is my pleasure to welcome you all to the Women in Tech Dinner tonight on behalf of the women of Edge Engineering at Netflix. My name is Sangeeta Narayanan, and I lead the Edge Developer Experience team. We have a fun evening planned for you. I'm going to kick us off with a brief intro, tell you about Edge. I heard somebody ask, so what does Edge do? So I hope about it at the end of it all. And then following me will be my colleagues, each of whom will go over different parts of the Edge architecture and the components and services they work on. I'll be back to wrap things up, and then we go to the most fun part, which will be dinner. All right, let's get started. Raise your hand if you watched Netflix last night. Good. What were the rest of you doing? Now, raise it again if it worked flawlessly for you. Now, I'm going to live dangerously here, I know. Okay, pretty good. That's excellent. That's exactly what we like to hear, and that's exactly what we hope to hear from the 117 million subscribers that we have in over 190 countries worldwide. And those subscribers can choose to consume our content on over 1,000 different types of devices. And all those subscribers and all those devices add up to a staggering 140 million hours of content streamed every day. That's a lot of TV. Where does Edge Engineering fit in? We are responsible for the services that power the core Netflix experiences. Sign up, title discovery, and playback. Anytime you interact with the Netflix app or the service for any of these experiences, our systems are in the mix. Another way to think about it is if any of our systems is down, then you will not be able to play. And we will be trending on Twitter for absolutely the wrong reasons. So that creates an interesting dynamic for us. On the one hand, we want to deliver a compelling product to acquire more members. And on the other, we need to provide a highly available and reliable experience so that people continue to come to us to enjoy more and more of our content. We wrestle with this dynamic on a daily basis, and the theme for today is going to be how we run a highly available and reliable service. And you'll hear from my coworkers how we use a combination of architectural patterns, operational best practices, and a robust set of tools to help us deal with this delicate balance. Real quick, the services that comprise Edge. So devices here on the left talk over the internet to Zool, which is our routing and traffic shaping tier. It provides resiliency, security, etc. Next up, the request hits Notework, which is a tier that is responsible for delivering a highly optimized experience for each of those device types that we support. Requests then go to the API tier, which is an abstraction over the microservices that run in the cloud that form Netflix. And one of those is a playback licensing service, which provides the content licensing and DRM, digital rights management functionality for our content. And underpinning all of those is a robust suite of developer productivity and operational insights tools, which allow us to develop and operate these services at scale. And so with that, you're going to hear about each of these services and systems from my coworkers here. And I'm going to start things off with Kaya Varadarajan, who's going to be talking about Cloud Gateway.
Thanks, Sangeeta. So, hi everyone, I'm Gaya Varadarajan. I am a senior engineer in the Cloud Gateway team. I'm here to talk about Zool. So Zool is the front end of the Netflix server infrastructure. So Zool handles traffic from thousands of devices, streaming tens of billions of requests in a day. You can think of Zool being analogous to traffic steering, routing, and insights. You can ask me, why have Zool? Why not steer the traffic from the cloud all the way directly to the backend? There can be a myriad of things that can go wrong in the internet. For example, let's say a TV provider pushed a bad config that causes all the Netflix app globally to just restart at one go. True story, but that's why we have Zool here to do the heavy lifting. And because of its inherent non-blocking nature, it is naturally resilient to high volume of traffic. So it gives the backend systems a breathing room to cope with this new traffic. Now, Zool and our backend tiers are all deployed currently in 3 AWS regions. And the one cool thing about Zool is that Zool can talk to other Zools in the other AWS region. So let's say if one of our backend component goes wrong, we do not want to ruin your beautiful evening of Netflix and chill, right? So we use Zool's capability to talk to the other Zool to steer this whole traffic in the bad region to the other healthy region, so you can still enjoy the title you want to stream. And if this is not convincing enough to you of why we have Zool, here is a bird's eye view of all the different things that Zool offers. As you can see, it is really the critical component of the H tier. So if Zool goes down, Netflix is down, and we do not want that. So as I said, since there are tons of things to talk about and it is impossible to cover all of them, I'm just going to focus on self-service routing and canary. In the beginning, when we were just growing, we had like fewer request changes for route configurations, but then we started to add more content and we started supporting more and more devices. So the backend developers started coming to us with more requests to route changes. So to cope up with this, we were motivated to create this mechanism called self-service routing. I know it's a mouthful, so I'm just going to call it as SSR from now. So using SSR, a backend engineer, she can configure her route changes, tune it, and basically be confident that Zool is going to give her all the insights she needs. So we in the gateway tier doesn't have to babysit her. For example, she can basically say, okay, this type of traffic, use Zool to configure to go to backend B and make it as the primary route. Or she can basically say, okay, I'm going to ramp a new backend, so I will use Zool's SSR feature to take a small percentage of traffic, use Zool to route to the new backend where she can basically analyze all the insight we give, and then when she is confident, she can slowly ramp more traffic to the new backend. SSR also helps really great in the production debugging. For example, if there is a production issue, the on-call engineer can quickly create a new rule that says, hey, route this matches this criteria that she suspects to be the starting point to a single instance debug layer where she can actually analyze what's going on. As you see, there is tons of things SSR offers. One of the other thing that SSR provides is to basically give her the ability to test the backend performance. So she can slowly start ramping up more and more traffic to the back end and kind of see how the system metrics scale with respect to the RPS that it can handle. Thus, she can establish a benchmark for her system. Now, we can use Zool to also configure, like to reject the spammy traffic or give some security rules. So if Zool detects there is some anomaly detection, she can configure the rules to just reject the traffic and not even make it to the backend system. So as we know, when we are all searching for something in Netflix, you want the result to be snappy. Whereas I'm working with a partner and who cares, right? It can be 5 seconds, 10 seconds. So for every different workflow, you need to be able to configure different timeouts. So we can use SSR to configure timeouts for each of your new workflows. Another cool feature that Zool offers is a mechanism called Sticky Canary, where Zool selects a small set of users to make them go through their new workflow, and she can collect all the insights she needs for her use case, whereas Zool will periodically rotate these users. So don't worry, you're not going to be stuck in the bad workflow. And if you're, just to give you an idea of how this rule configuration works, here is a UI. She can basically pick the match criteria, select her routing action, and then once she creates this rule, we basically use some real-time analytics to kind of guide her like, hey, your rule actually matched this many of the samples that we got. So in this case, it kind of conflicted with an existing rule, so we just rejected this request. So now, yes, I did intentionally mention she and her in all my presentation, but don't you think it's about time? So with that note, I pass it on to Kim. Thank you.
Hi, my name's Kim. I've been at Netflix, just to give you a little background, I've been at Netflix for over 10 years now and started off in the UI engineering group before it was even called that, and worked on the website when we were really just a DVD by mail company, and now over the years I've migrated to be deeper on the server infrastructure side. So really excited to talk to you today about the work that my team does in our part of the tier. So many of you are probably familiar with this image. This is something you would see if you're using one of our TV connected device UIs. And then this is our mobile user experience on iOS. Now, one thing that's really important to Netflix is continuously innovating on the user experience to deliver the best possible member experience. And so we're constantly changing and evolving the user experience. So these UIs, they look similar. They're both Netflix, and they're both showing you titles that you might want to watch, but they're actually very different. They show different kinds of metadata based on the form factor of the screen. On the TV device, we have a lot of real estate to be able to show you a richer amount of metadata. We also have different imagery that we show at different sizes. So in the TV experience, you can see we're using horizontal imagery and we use vertical imagery in the mobile experience. So we actually need very different data to fulfill these two user experiences. And that's why I love my BFF. And no, I'm not talking about best friends, though I do think for some of the engineers who use the BFF at Netflix, they may think of it as their best friend. What I'm actually talking about is backends for front ends. And it's always fun when you realize that something you've been doing for a long time within your company is actually being done at other companies in the industry, and that there's a term for it. A few years ago, Sam Newman blogged about the BFF, and I only recently stumbled across this term, and that's always a fun thing when you realize something you've been doing has got a name, the BFF. So what is the BFF? What we're really talking about here is putting services into the cloud that are uniquely tailored to the needs of an individual UI or device application. And at Netflix, we actually enable our UI engineering teams to write their own code and deploy it into the cloud so that they can completely control the request and response lifecycle and deliver exactly the data that they need for their individual device. So you can think of it as a translation layer that enables them to write their own business logic and customization and deliver it back to the device in exactly the format that they want. This enables them to rapidly iterate on the user experience and do that kind of A/B testing that we do without needing to coordinate necessarily with the mid-tier back-end teams to change their responses. And it also enables us to have thinner, more focused services. And so how do we provide that in Edge? Well, we provide that through platform as a service. So we allow engineers to develop, run, and manage applications without the complexity of building and maintaining infrastructure. So what we like to say is, you bring the code, we'll do the rest. They deploy their code to us, and then we manage the infrastructure, we manage the capacity and scaling of that, and we hold the pager for them. So we're operating these services for them in production. And this enables these UI engineering teams to stay very focused on their core charter, which is working on the front-end application and improving that. And it allows us to ensure that we have high availability and resiliency of these services in the cloud. One more point on this. The reason it's called NodeQuark is that we're using Node.js as the technology for this platform. It's really best fit for most of our UI engineering teams because a lot of them are developing in JavaScript already. So it's a natural fit for them to be able to write this code and their business logic in JavaScript because they're also writing their front ends in JavaScript. And another great thing about this architecture is it affords us a lot of isolation. Each team's code is isolated from each other. And this allows us to isolate failure. If one team deploys a bad change, it's not going to impact all of our devices. It would just be isolated to that device. It also gives us better ability to root cause issues, as well as giving us more fine-grained capacity management. As was mentioned previously, we have many, many devices in the field, and they have varying traffic patterns. Some devices have less traffic, some have more. It might depend on the region they're in, the time of day they're being used. And so this allows us to manage the capacity more tuned to those individual devices. And through all of this isolation, we can also better understand the performance of individual services and devices in the field. Now, while having the BFF is really great, if these teams had to integrate directly with the Netflix mid-tier, it might be overwhelming for them because they would be integrating with, potentially hundreds of microservices. So that wouldn't enable them to stay focused on their charter. And that's why the API service layer exists. And that's what Karen Casella is going to talk to you about next. But don't hesitate to come talk to me at dinner afterwards if you want to learn more about anything that I was talking about.
All right, so show of hands, who's familiar with sharding? Okay, who's familiar with sharding but not in the context of data or databases? Okay, a few hands, mostly from Netflix. Awesome. So I'm going to be talking about a different type of sharding tonight, which is traffic sharding. And we're going to talk about that in the context of how we maintain good availability and reliability of our API service layer. But now that I've whet your appetite, I'm not going to talk about sharding. I'm going to talk a little bit more about what the API service layer is, and then I'll come back to our sharding approach. So as Sangeeta introduced, the edge engineering systems are responsible for delivering the user experience to the clients that are attempting to view content on Netflix. So the API service layer has a very critical part in that. For example, the API service layer is responsible for orchestration of data from the front-end systems that Kim was talking about. When the requests come into API, the API layer will make the calls out to all of the back-end mid-tier systems to get that data, bring it forward, aggregate it, do whatever it needs to do, transform it, and give it back to the front end. So that's an important piece of what it does. Another piece is the availability protection. So for example, if any of our mid-tier services or downstream dependencies go down, API will protect the user experience from any outages. Our first priority is the ability to stream content to the users. So we prioritize that path, and we provide the ability to do fallbacks in the API layer so that we can continue to serve content to the end users. And then finally, another key component of what the API layer does is creates a layer of abstraction so that the front-end systems don't really need to know the details of what the back-end systems do. It will do the abstraction for that, as well as provide things like caching and bulk APIs and that type of thing as well. There are challenges in running a system as large as API, and it has been in the past a rather monolithic approach to how we do the API layer. The first key challenge is observability. When you have a huge system doing all these things, it's really hard to kind of pinpoint what might be going wrong. So for example, if you see a flame graph that looks like this one, it's not going to really tell you much. There's just way too much information. So we needed a way to reduce the time it took for us to detect and debug problems in the system. Next, we also needed a way to reduce the time to resolve any issues that we had. With the old API architecture, it took almost 30 minutes to start up new servers. So if we needed to spin up new servers to run an old build or run a new build or bug fix, it was just really slowing us down. So we needed a way to kind of isolate the system so that we could spin them up and identify the issues and resolve them more quickly. And then finally, Kim talked about this a little bit too around isolation. We want to be able to reduce the blast radius of any problems that we encounter. So for example, if we have a bad code push, instead of it going out to all of our API servers, it'll just go to one section of the API farm. And I'll talk about how we do that in a second. So we needed to not break the monolith. We decided to shard the monolith. And there are two different philosophies or two different strategies that we've used around sharding within Edge engineering. One is we think about traffic criticality. And I'm going to draw upon an example in our licensing systems. So acquiring a license is a very critical operation. If you can't get a license, you can't stream content. Releasing a license, maybe not so much. So we consider that non-critical traffic. That way, what we do in the licensing team is we deploy our code to our non-critical path first, so that if there are any issues and we have an outage, it's not going to really affect us too much. Then we'll redeploy it to our critical servers. That way we can isolate any issues that might come up. The other approach, or the other strategy that we've been using is around traffic volume. So we can segment traffic based on function or feature. So we might take all of our search traffic and send it to one set of API servers. Or the other approach is around the source of traffic. So what devices are coming in? And that's one of the approaches we've used in API, where, for example, we have a mobile shard. So all mobile traffic goes to that one shard. It's tuned for mobile traffic, and all of the systems are highly performant for those clients. Similarly, we have a smart TV shard that handles all of our TV traffic. We could scale independently. If we're getting a lot of TV traffic, we have a much larger farm. If we have more mobile traffic, same type of thing. So what have the results been? We've seen an amazing reduction in the time to debug and detect issues. Also reduced our time to resolve by reducing our startup time on our servers by more than 20%. And then finally, we've increased the reliability by reducing the blast radius of any changes. And just as an example, you guys might watch a lot of Netflix at the holiday time. A lot of people watch Netflix during the holidays, and that's our highest traffic time of the year. We had 100% availability this past year because of the work that we've done here, and we're very proud of that. So there be dragons. In any kind of system evolution or re-architecture, there are going to be things that are going to bite you in the butt. We had some missteps along the way. For example, Gaia talked about the custom request routing. We misconfigured some routes. We had some issues, but we learned from it. But despite the fact that there's a lot of overhead in configuration and a lot of operational complexity, we truly believe that the work that we've done here has increased our availability and made our systems a lot more reliable. So I wanted to introduce Daniela, who's sitting here. She's an engineer on our API team. She'll be at dinner. You can join her at her table to talk about the API systems. And if you want to talk with me about any of the other systems that we have listed here, please find me at dinner. And next up, Hari Priya is going to come up and talk about our licensing systems and how we make those available, highly available and resilient.
Thank you, Karen. So let's imagine we all had a very long day, finally done with everything for the day, and we find our remote somewhere, hidden in the couch. We find it, we log into Netflix, and find our favorite show, and hit play. And if you end up seeing this, it's going to be really frustrating. So one of the reasons why you might end up seeing this is if the device trying to play back can't get the license. So I'm Hari Priya. I work on the playback licensing team. I'm kind of a newbie here. I've been here for about 2 months now. I'm going to talk to you more about my experience on working on a project, initial project. So before going into that, we get all this interesting content that gets ingested into our system, and the content then gets encrypted and chunked, and the chunks go to the CDN, they get stored there for easy and quick access, and the keys go to the key server, key store. So then what happens is, when the device is trying to play back, they first fetch the playlist, which gives them the URLs for the content, but the devices can really do nothing with it unless they have the key for decryption. And so they have to get the license, and the license is going to give them the key to decrypt the content, and they can start a seamless playback. So license is the final piece of the puzzle that provides them the key, the decryption key actually, that can actually be used by the devices to decrypt and start the playback. So as you can see, license is actually one of the critical systems. Many other services have the option of providing fallbacks when they have issues, but with licensing, that's not an option. You either have the key to playback, or you just can't start playback. So, and with like many other microservices, we also have multiple microservices that we talk to before we find the license that we have to return. We build the license that we have to return to the device. So for instance, if API requests, device requests for a license, the API team, the API server is going to make a call to one of the license servers to say, okay, get me the license for this particular device. And this playback server, or license server, sorry, would actually make multiple hops, and then finally build the license that the device can understand, and then can start playback. And at this point, any of these services can have an issue. But we can't just let this affect our SLAs with API, otherwise you would end up seeing that loading screen. So we actually build a lot of resilience in our system. One of the tools we use is Hystrix. We use Hystrix to build fault tolerance and resilience. Hystrix provides bulkheading. It stops cascading of issues. It's also, you can also fine-tune your timeouts so that you can say, okay, I want to give up on this server at this point and then try on a different server. So as a new hire, I got a chance to tune the Hystrix timeouts for most of our licensing services. What I did was to figure out what do I tune these values to. I was able to actually bring in some production data, really production data, and actually run some tests to know, okay, what's the right value I can tune my services to. And then once I figured out the values, I plugged in the values, and once they were all deployed, I could run chaos tests and actually validate the results. So what we ended up doing is we introduced latency into one of our services on purpose, and then we were able to see that the license server was able to still respond on time without issues. So Haley is going to be joining us for dinner. She works on chaos engineering. If that interests you, go find her at dinner. Next, Sangeeta is going to be talking more about the tools that we use, which help us develop easily and deploy with full confidence. So over to you, Sangeeta.
Thank you. Okay, it's me between you and dinner. So for those of you who watched last night, if you were to go visit Netflix right now, the software that's running and serving up your experience is very different from the one that was running last night. To give you a sense for how different, take a look at this. We're talking about hundreds of changes over just a 24-hour period. And so what's driving this rate of change? You heard a lot about product innovation. We are running hundreds of A/B tests over the course of a year, and the product experience is continuously evolving. So what this translates to for us in engineering is an idea and put it out in front of our members as quickly as possible. So I'm going to give you an example of how we enable that type of velocity. So if you might recall that let's say if you're an iOS developer, how our architecture works is that in addition to your client-side software, you also own a server-side component, a BFF, right? And in production, the traffic between your client and your server is routed via Zool. And what we want is to be able to give our developers the ability to iterate quickly on both their client and server-side components, right? But and get quick feedback in an environment that mirrors production as closely as possible. So here's what we do. An iOS developer here can run their client code here or on their device, on their local laptop or on their device. And we host Zool in the cloud, so they don't have to worry about it. And we leverage the capabilities of Zool, amongst other things, to be able to route the request back to their service running locally. And this is just one of the ways in which they're able to iterate rapidly and get quick feedback. And what this does is reduces their dependence on shared environments like staging, which are inherently high friction places to operate in. So this is one example of the ways in which we enable our developers to move fast. Now, moving fast is great, and it really helps the business innovate. But given our scale and complexity, it can be risky. Our strategy here, or our philosophy here rather, is to embrace failure. We know things are going to fail, and what we choose to focus on is the ability to detect, recover from, and root cause issues very quickly. To that end, we have a robust set of observability tools that provide various capabilities, such as the ones listed here. I want to zero in on one for a moment. We refer to that as our domain-specific insights. And this is important because, as you heard, playback is core to what we in Edge do, and of course, it's core to Netflix, right? And here, what we want to be able to do is empower, if we go back to our iOS developer example, our iOS developer here to quickly able to get to the bottom of an issue. So this is the root cause part of the process that I was talking about earlier. And what we've done is layered on application context and intelligence on top of a fundamental building block like distributed tracing, which helps our iOS developer in this case hone in on possible root cause for a problem. And so they don't have to have the domain expertise that our playback teams have. So this is one example of how we bolster the safety net that we provide for our developers, even as they're trying to sort of reduce the risk inherent in introducing a change. Ours. Now, you heard a lot about technologies and systems and services that power Netflix. I want to take a moment to talk about the people. This chart here shows our growth over the past few years. And it's impressive. And what we want to do is, it's not enough for us to be able to scale our systems to handle this kind of growth. What we want to be able to do is to scale ourselves and our engineers as effectively as we scale our systems. Because we truly believe that if we want to be able to move fast and be safe and balance the needs of the business and our members to offer a great experience, we need to be able to stay calm and have fun throughout the process. So if you'd like to learn more about any of what you heard, the tech blog and our GitHub site are great resources to go check out. And with that, I would like to invite you all to join us for dinner. Tables are outside, and please join we have allies from Edge Engineering who will be joining all the speakers. So hope to see you there. Thank you.